let us start the live session. I hope so I am audible. I hope so I am audible. I hope so I am visible. Camera feed is coming very nicely. Yep. So there we go, we are live. Alright. Hey guys, welcome back to Coders Arcade. This is Ashank David and welcome to session number 29 of DSA live session for placement series. In this live stream, we are covering all the DSA concepts which we have done, which what are going to be asked in interview. So if you are new to this channel, please don't forget to like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Now, also before I start with this, please share this live stream to as many people as possible. So for those people who really wants to learn DSA for their interviews all for free, they can also get to this point. Well, without any further ado, let's guys start it. So, what exactly we are going to learn in today's class? Guys, one more thing, again I am saying, if there is any issue with my mic, please do let me know. I hope so that I am audible. I hope so that I am visible clearly. The font size and everything is visible. I am the only one operating the camera today, so apologies if the feed goes take off a little bit again, so in between, but bear with me, okay? Because I am the only one here to operate the camera itself as well, okay? But anyways, let us start our class today, guys. Today, the question is what we are going to learn. In today's class, we are going to learn about heap data structure. Very important data structure. If you ask with the based off of the perspective of interviewers, this concept is a very important concept, guys. You cannot leave this concept like that. You see, heap concept is a very important concept because a lot of things are done in heap using this, and the questions are asked. When you will solve the data structures problems related to graphs, then at that time you will be requiring the heap data structure. Like for example, when you are doing Dijkstra's algorithm, you will be writing the minimum path finding algorithm. At that time you need a minimum heap priority queue. When you do MST, minimum spanning tree, at that time you need again minimum heap. So heap is very important. Before heap, you have to understand about priority queues. What are priority queues? What are the types of priorities? How do you create a priority queue? All of those things you should know very well, which I have covered in the previous session, the yesterday's session. If you guys have not watched our yesterday's session, if you have not watched my yesterday's session, I would ask you guys to watch my yesterday's session. In yesterday's class, I have told this 100 times that in today's class we will require the yesterday's concept. Priority queues. What I have explained to you about priority queue is going to be applied here in order to solve all the problems related to heap data structure. So make sure that your priority queue is also done. If not, you know where to go. Coders Arcade, you have the playlist. Just before this video, this is the continuation in that in the playlist. Okay, so just before this video, you can watch that. Now, without wasting any time, also one more thing before I start, do not forget to subscribe to our Telegram channel, which is very important. Telegram is very important here, guys, because there I keep on posting all the notes of whatever we are doing in the live. Well, notes I'll give the description, I'll give the link in the description below, guys, for that, not a problem. Apart from that, anything related to mock interviews, companies interviews, entrance tests, or related to internships or placements, I'll be posting that in the Telegram, and we are working on to that concept, guys. Mock interviews, as I was saying, I am still working on it, creating some questions so that I can come live with you guys. So stay tuned for that also. And without any further ado, now let's start our class. today's class main concept is gonna be our heap data structure. Oh, and I forgot to open my whiteboard. Just give me 1 second, guys. Our Microsoft whiteboard, very important. Now for 1 second you might feel very bright, but wait, in just a minute you will be fine. Okay, so here we are, and there you go, much better, now much better. Okay, so I hope so that the brightness is very much clear, brightness is okay. Now the ISO and everything is fine, because I am only operating the camera today. So guys, I hope so that this is very much clear, and this is a little much better now. Okay, I have increased the ISO. Okay, alright guys, so we are here again, and any doubts related to this session, please do let me know in the chat, in the live chat. I am watching the live chat window, so if you have any doubts related to the concept which we are doing, you can go ahead and watch our live feed. A live chat, you can talk to me directly in the live chat. Let's start. So today our main concept, our main point of interest is going to be what? Heap data structure. Heap data structure, guys. We are going to talk about heap data structure, guys. A very important concept, as I told. Now what is this heap data structure? The heap data structure. 1 second, guys. Apologies for this. Okay. What is the heap data structure? Heap, as I said. Heap is what? Heap is generally what you say in heap. What is the meaning of heap in English? In English, heap is what? Pile. Pile of something. Or you can say random collection of something. I am talking about something right now. Random collection of something in a shape of a mountain. If you might have seen, when there are dried leaves fallen on the ground, when we sweep them, we form a heap of leaves, of dried leaves. Have you ever seen that? Everyone have seen that before. Okay, that is a heap. The good example, as I told you, that dried leaves, tree leaves, when they fall down to the ground, and when we sweep it, what happens? We collect it in a shape of a heap, a pile of fallen leaves. That is heap in general. That is how a heap looks like, and a heap is in a shape of a mountain, guys. Correct? Understood? So in this case, the data is also stored in a shape of heap, like this. The shape is kind of like this, where the data is stored, or something is stored in a pyramid kind of shape or a mountain kind of shape, randomly, as simple as to understand this. I hope so that this is very much clear. Okay. So this is your basic heap shape that you see. That is the heap shape that you see. Now guys, what is the relationship between a heap data structure with this English heap meaning? Let us try to understand this in a very simple way. Okay. What is that? When we are talking about heap, we say it is a data structure. Right? Heap, it is a data structure. Data structure is what? data structure stores the data. You got my point? The heap data structure stores the data, and here basically I can see data being stored in a heap type of configuration, where the data is kept like this, one upon each other in the shape of heap, kind of like a tree structure only. We can say kind of tree shape structure, In a very simple layman's language, I am trying to explain you guys this. Understood? So this is how you see this. What is the benefit of storing the data in the shape of heap like this, forming a mountain or forming a pile? The main task of storing the data in the heap style of configuration or a tree shape structure is that the data which is kept on the top, of the heap, right here, the top of the heap, that data is this is accessed first. Understand the point? Because you think about it, when you have some pile of some random clothes, for example, you have a heap of clothes. Now when you try to pick up the clothes from that heap, the very first cloth that you will pick up is from the top or the peak of that heap. I hope so that this is very much clear and easy to understand in the beginning. That is the general approach here. That is the advantage, that the first element which is kept on the top of the heap is accessed first. That means if we talk about a tree data structure, imagine a tree data structure. Let us say we have stored some data 100, 20, 30, 40, 50, 60, 70. Now we don't care about the configuration of the data placed here. Okay, we talk about the numbers which are placed on the top. This is not a binary search tree, guys, but it is normal binary tree which I am trying to explain you here. Okay, so here this element is on the root of the tree, which is basically the top of the heap. Heap looks like this only. So from the heap data structure, when you access anything, you access the root and you access the major root, and when you access the root, it is accessed in the time complexity of O of 1. The extraction time complexity comes to be O of 1, big O of 1. And when this happens, the element which is on the top or in the root will be accessed first and will be accessed easily. This is what happens in this heap, and that is the reason why whatever we are trying to, like for example, what I am trying to actually explain you is a priority queue, QUEUE of heap style, the priority queue of heap style. This is very important, guys. In the yesterday's class I told you that the priority queue can be created in many different ways. We can create the array, we can create it using the linked list, we can create it using the trees concept, and last we can create it using the heap concept. Yesterday I have explained you this or not? Yes. In the priority queues concept, I told you these 4 are the ways that you can do it. The array implementation is okay, but it is not efficient. The linked list is also not as efficient. The trees is also not as efficient. Trees in the sense, basically you have BST. We are talking about BST. Binary search tree it is. Okay. This is also not as good. But heap is the best. Now my camera went off, guys. 1 second. I'll be back. There you go. We are back. Okay. Apologies for this. I'm alone operating the camera also, so bear with it, guys. Okay. Heap data structure. Let's continue. Heap data structure is the best option here. Heap data structure is the best option right here. That is the reason why today we are learning the heap data structure. Today we are learning the heap data structure. Is that clear to all of you guys? If you have any doubts, please tell me in the chat below and I will clear your doubts. Alright. Next. So this is your heap style. Okay, priority queue. Ultimately, we need to create our priority queue. This is our main task. Priority queue is our main task, guys. I hope so that this much you have understood it really, really well. Okay, guys, let's move on. So today, before I start with this, I have brought you some heap data structure notes. Now don't worry, guys, these notes are not my notes. This is just copied from internet, compiled into one file, so that you guys, it doesn't, we don't waste time in going to different sources and understanding it from there. But everything, every property, every advantages, disadvantages of heaps I have explained you here. So guys, if I explain you before I come to this point, if I explain it to you right here, then what exactly is heap? Finally, coming to the conclusion, guys, if I tell you heap is a data structure, heap is a data structure which stores the element to be extracted on the top. Okay, this is the thing. Why we do this? When we keep any data, on the top of the heap, when we keep any data top of the heap, then that data can be extracted first with time complexity of O of 1, which is best, which is imaginary. Understand my point? Imaginary. But we are able to do this. And how? Because of heaps. Understand my point, guys? I hope so that this is very, very much clear to all of you guys. Let's move on. Now, I will give the link of the whole notes in the description below, don't worry about it. Okay. Now, how does a heap data structure looks like? If we talk about a heap data structure looks like this. It is what? It is a tree only. It's a tree. tree shape we will understand. It is a tree where let us say 100, I have said 30 here maybe. Let's create a binary search tree. We can do a binary search tree quickly. Okay, I can say 120 here, I can say here 10, I can say here 40, I can say here 110, and I can say here 150. Okay, so like this. So this is what? This is a binary search tree, and don't bother about the binary search tree here. Don't bother the concept of binary search tree. Okay, let it be. I am saying that we are trying to access this element. This is the major thing, guys. This is the element which needs to be extracted, is kept on the top. So here the topmost element which is 100 will be extracted first. I hope so that this is very much clear to all of you guys. If you have any doubts, please do let me know in the chat below. Okay, now there are majorly two types of heaps. What are those? Number one, minimum heap, min-heap, and second one is maximum heap or max-heap. See, min-heap is where the topmost element is minimum. Okay, and here the topmost element is maximum. That is the difference here. So guys, the example which I have shown you for 100, that BST one, is a type of what type of heap? It is a type of maximum heap. This can be called as maximum heap. Max-heap data structure. Alright guys, this is your max-heap data structure. So these are the types of heap data structure. I believe so that you have got what I am trying to say here in this case, and you have understood this really well. Okay guys, so this is what your heap data structure is. Now let us see, I'll just quickly go through the notes once quickly here guys, so that you get an idea of how we did it, and if I have missed anything, I'll just cover it directly from here. This is max heap guys, and see, heap is a binary tree based data structure that satisfies the heap property. What is the heap property? The value of each node is greater or than equals to value of its children. This property makes sure that the root node contains the maximum or minimum value depending upon the heap. So in this case, you see that this 150, 140, 50, now it is not necessary that it is BST only guys, it is not necessary that it should be BST, it can be a normal binary tree also. In the example I have taken as the BST, but you do not have to worry about taking the BST in this case, generally a tree data structure as I have told you. Okay. So this is just a heap. Now the element which I have kept here, you see, if I zoom in a little bit right here, you see that the element which we have kept here on the top is 100, means the topmost element is 100, means the maximum element is on the top, means this is max heap. This is min heap, where the minimum element, the minimum most out of all the elements in the tree is kept on the root or the top. This is what you call as minimum heap or min heap in this case guys. Okay, hope so that this is very much clear. Types of heap you have already understood, min heap and maximum heap. where the maximum value is kept on the top and minimum value is kept on the top. These are the three common common methods that we are using for heap data structure. And what are those? Insert, extract, heapify. Okay. Then you see, generally how we insert? We will add a new element to the heap while maintaining the heap property. Okay guys, we will do this, and then you will see extract the minimum or maximum depending upon what heap you have created. Is it maximum or is it minimum? Depending upon that, it will do the element of extraction. Extraction means we will pick up the topmost or the root of the heap, accessing the data there. Okay. Heapify converts an arbitrary binary tree into a heap. Understand my point, what I am trying to say? Heapify is the major important, very highly important function, guys. Okay guys, so listen to my class carefully from this point of time in this session. If you have not understood the heapify method, then you are gone. Basically, this is the heap sort technique of any thing, any heap basically. This is heap sort. It means we are just heapifying the whole tree, means heap sort. I hope so that this is very much clear to all of you. Okay guys. Now, heap data structure applications. Heaps are commonly used to implement priority queues, as I have explained you right now, that majorly priority queues are used for any priority related task, of course, but they can be done in arrays, linked list, and trees, and heaps, and heaps are the best ones to do it. So do not forget that, guys. Clear? Heap sort is the sorting algorithm. Of course, we know this. Okay, we have already understood this. Heaps are used in the graphs algorithm, as I have already told you. Heap priority queues are used in graphs like Dijkstra's for minimum path finding, MST, Prim's algorithm, Kruskal's, a lot of places we will be using them. Okay guys, properties of heap. It is a complete binary tree. Okay, it is a complete binary tree. While I was teaching you the session for binary trees, I have explained you what is a complete binary tree, guys. Okay, complete binary tree means all the levels are filled except for of the last level. I hope so that this is very much clear in the binary tree. Heap tree is a complete binary tree, meaning all the levels of the tree are fully filled except possibly the last level, as I have explained you right now, guys. Understood? Which is filled from left to right. This property ensures that the tree is efficiently represented using an array. Here we are talking about this, guys. Today we will explain and understand the heap implementation using an array. So basically array implementation of heap data structure. Alright guys. Heap property. What is the heap property? This property ensures that the minimum or maximum element is always on the top according to the heap type. Is it max or is it min? The maximum or minimum value will be kept on the top. Understood? Parent-child relationship. Now very important concept, guys. Imagine there is a whole array itself. You see, I'll tell you. You see, the relationship between a parent node and index is I, and its children is given by the formulas for the left child as index 2i plus 1 and right child is 2i plus 2. Now, half of the people will not understand what the hell is this. Okay. Let me explain you this. Let me explain you this. Okay. Say for example, this is a tree data structure. I have said 100, 40, 30, anything, 50, 60, 70, 80. This is our binary tree, guys. Okay. Now, if you convert this binary tree, if you convert this binary tree into an array, then how would you do that? This is the array. This is the array. Who is the root? Root is 100, let us take this as, and the index is here. How many nodes are there? 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, okay, 0, 1, 2, 3, 4, 5 and 6. So, this is our array. User, please disable pen pointer highlight while writing, it is distracting. User, the circle bubble highlighted to, oh, okay, user, oh, okay, this, you are able to see the circle. I cannot disable it, it is by default coming into my Microsoft whiteboard. There is no setting for that also. We cannot disable it. There is no settings to disable it. Okay, we cannot disable it. It will come. Usually, it will come. See, when I am touching the board also with my fingers here, it is going to come. So, yeah. Shouldn't the 30 be replaced with 40 because the left child should hold the lower value? Yeah, let me explain that. I hope so. User's doubt is clear. Next, Madhukar Verma, we can implement a heap as a normal binary tree also, no problem. Okay, it is just a tree which I am explaining you, giving you an example of. Okay, you are thinking that that it is a binary search tree. It's not necessary. It is not a binary search tree. We can directly create it as a binary tree also. No worries. Okay, user, your doubt is clear. And Madhukar Verma, I hope so that you have also understood. It's not necessary for us to maintain the binary search tree. Shouldn't be 30 on the left replaced with 40 because the left child should hold the lower value. Yeah, I hope so that I am clearing with your doubt. Okay, guys. It's not necessary that it is binary search tree. It can be a binary tree also. In binary tree, we can put the elements anywhere we want. Understood? So now if we are converting this binary tree into, this is not BST. If we are converting this binary tree into an array, then the first element is usually the root element. The root is placed on the top, right here. The root element will come right here. Okay. So now I said 100 goes right here, which is I, and my camera went off. 1 minute, guys. Right there. Okay, yeah, I'm back again. So guys, this is I. Okay, this is I. I is what? The parent. The parent. I is what? The parent. I hope so that this is very much clear to all of you. And the notes says that the relationship between the parent and its child, when the left child is at 2i plus 1, 2 into I plus 1, 2 into I plus 1, 2 into I plus 1. That means if I say this is I, then this is 2i plus 1. This is 2i plus 2. In terms of array, this is array notation. Okay, I am writing it very small. This is what? Array notation, ARR notation. Understand a point? So that means the left child 40 will be placed right here. If I want to take out its thing, do it. 2 into I is currently staying at 0 plus 1. 2 into 0 plus 1, which is equals to 1. On index 1, you will put the left child, which means this child will be kept right here. I hope so that this is very much clear to everyone watching this live stream. Understand a point? This is 2i plus 1. This is left child, this is left child. I hope so that this is very much clear to all of you guys. So this, it is written, see, it is given to us. Parent child relationship, the relationship between a parent node at index I, parent node at some index I. This is the parent, this 100 is the parent, and this 100 is the parent, of course. The root and its child, the left child is 40 and the right child is 30. Okay. So, in this case the left child is at index 2i plus 1 and the right child is at index 2i plus 2. So, that is what I am proving here, that the root is 100 which is 0th index I, its left child is stored at 2 into I is 0 right here, into 0 plus 1, that is going to be the left child. Understood? Right child on the other hand is 2 into I plus 2 in this case. That means 0 plus 0 into 2, 0 plus 2, 2 index. This 2 is the right child. What is it? It is the right child. It is the right child. So, here it is 2i plus 2 and this is the right child. Right child. I hope so that this definition, explanation to how the left and right child are calculated is understood. Understood? So, in this case this is 2i plus 1, this is 2i plus 1, 30. 2i plus 1 is coming at index 2, means that 30, this 30 will come right over here. Okay. So, this is that 30. Okay. Hope so that this is very much clear to all of you guys. Okay. Now, if you check for the 40's left child, 40's left child is gonna be 50, again 2i plus 1 in this case. So, 2 into I, 2 and I is 1 right now. Now, this is the updated I. So, 2 ones are 2, 2 plus 1, 2 plus 1, 3, that means this index. So, 40's left child is 50 and 50 will be placed right here in the array. Any doubts, guys? I hope so that this is very much clear. Now, for its right child, if you see, right child will come at 2i plus 2. So, 2 into 1, 2 ones are 2 plus 2, 4. So, 40's right child will come right here at 60. Understood my point? So, this is calculated like this. Understood? So, I can say 40's left child is 50 and 40's right child is 60. On the other hand, 100's left child is 40 and 100's right child is 30. This thing is probably, I hope so, that very much clear to all of you. Understood this, guys? Similarly, if you take out the I as, now take this as I, updated I, take this as updated I. So, in this case, if this is the updated I, then for twice into I plus 1, 2 2s are 4, 4 plus 1, 5. So, index 5. So, for this, its left child will be at 2i plus 1 again. That means 70 is written at this place, 50. Hope so that this is very much clear to all of you what I am trying to say. This is 70, right? Put over there, this, and at last 2i plus 1, 2i plus 2 it is now, for value I as 30. So, 2 to the 4, 4 plus 2, 6, means 80 will be placed right here and this guy will come right here. I hope so now all the iterations and tracing you have understood this really well. Okay, guys. So, this is 2i plus 1 and 2i plus 3 for the parent and child relationship. So, this point is proven. When we are doing heap data structure, when we are doing what? Heap data structure. In terms of arrays, we will calculate its left and right child with the help of the formulas like this. Clear to everyone, guys? Hope so that this is very much clear to all of you guys. Okay, so I can say here that 50's 30's right child is 60, left child is 60 and 70, like this. 60 and 70. 30's left child is 70 and, okay, sorry, not this one, this one, this one and this one, and for 40 it is 60, and for 40 it is 50 and 60. Well, you got my point, guys. Clear to all of you. So this is your parent and child relationship between the elements into the heap. Okay. Now, what else? Effective insertion and removal. This is the main point here, guys. Okay. Insertion and removal operation in heap trees are very efficient. New elements are inserted at the next available position in the bottom rightmost level, and the heap property is restored. Okay, I'll explain you this. Directly. Understand this. This is an example of insertion. Now we have the binary tree here, 8, 4, 5, 1, 2. When we want to insert, this is a complete binary tree. Yes, it is a complete binary tree. How do we know? Because here all the levels are filled except for the last level. From left to right we will fill it. Absolutely fine. This is okay. Now if we want to insert 10, so 10, where it will be inserted? On the available left to right position, which is 5's left. So 10 will go right over here, guys. I hope so that this is very much clear. And once the 10 is kept here, now you see it distorted the property of heap, because till now if you see here, this was a max heap, because 8 is the highest element which was kept on the top. This was coming as max heap, but when I inserted 10 right over here, it distorted the property of max heap, and now it has become a normal binary tree. So to replace this, we will use the heapify operation, and heapify operation will bring up the 10. Hope so that this is very much clear to all of you guys. Understood? Then we are talking about deletion. So when deletion happens, we are directly going to be seeing this. Deletion happens at O log n time in this case. Okay. Let us say we have 15, 5, 7, 2, 3. This is a maximum heap, max heap. Okay. Now if I delete anything, what I'll delete? 15 will get deleted in this case, because it is on the top. And when 15 gets deleted, you see the tree is again distorted, because 3 has come and took over its place. What happens is, the whatever last node is available, the last available node is always going to take up the roots position. No other node will be taking up any other position. Only the last leaf node will take up the concept. Like, this is very important for all of us to understand, guys. So make sure that this is very much clear to all of you, that whenever you delete anything, deletion will happen right on the root or the top of the tree, but when deletion will happen, it will replaced by the leaf node right over here. So now the element looks like this, the tree looks like this. Again it is distorted. So we will perform heapify, and it will heapify itself up and become a proper binary tree. I hope so that this is very much clear to all of you. Now this is how you delete the element. Now we have some extra things here that you can do. Get maximum for maximum element, for heapify function, and minimum remove or maximum remove, all of that we will see directly in the code. And here these are the advantages of heaps: faster access to maximum and minimum element, at O of 1 I have already explained you, because the element which is kept on the top is going to be extracted first, which means the time complexity comes to basically imaginary in the best case, sorry, in the worst case. So, that comes to be O of 1, guys. I hope so that this is very much clear to all of you. Do not forget this out. Okay. Efficient insertion and deletion operation will take it up in log n time. Okay. Then can be effectively implemented as an array. So, today that is what we are trying to understand here, guys, and suitable for real time applications. Okay. Disadvantages: not suitable for searching for an element other than maximum or minimum. In worst case, it will become O of n. Why? For that reason, binary search tree is the best. Heap is not the best, because heap, it is not necessary that every heap is a binary search tree. And if you try to search elements, it will try to maintain the heap property first of all, and when it does that, it does not take care of the binary search tree property, which makes it very bad for searching or sorting, because you cannot search, you need to search in the whole tree again. Understand the point? So, extra memory overhead to maintain the heap data structure. Of course, extra memory will be taken in this case, because every time we are doing anything, we are using extra memory. We will talk about this later on. Slower than other data structures like arrays and linked lists, but still it becomes one of the best data structures to implement. Okay. Now, directly let us go and see the code here. Let us understand the code. Okay, guys, this is the code here. Now, guys, of course, we will not finish the whole code today in just one session. Already the class has been stretched and time is about to get over. Let us not keep this session more than 1 hour, but I will continue the session tomorrow. But we still have 10 minutes of time, we can still do in this class. Whatever we are able to do it, we will do it. And I am not rushing, don't worry. People have complained with Ashank sir that Ashank sir is rushing, but I am not. Okay, don't worry, I am not rushing. Whatever is important, I will cover that. Okay, guys, I am not rushing. Okay, so we will continue, and effectively we will try to finish the course also in time. Okay, let us see. So, max-heap. So, we have created a max-heap class, and class max-heap we have created. In this, we have taken int star arr, a pointer of array representing the heap. We are gonna take, because we are taking arrays for implementation, we are taking the array. Okay, we are basically doing an array implementation. No, so I have created the array pointer, no problem. Later on, we will allocate the memory dynamically using the either the size or dynamically allocating the memory using macro substitution preprocessor directive. Okay, later on we will see that. Int star arr, this is the array pointer here, and I said that max size is the maximum size of the whole array itself. The maximum size of the whole array itself. Max size is gonna be the maximum size of this array which we have created right over here. Remember this, guys. Okay. Int star arr is the array size, the heap actually. The max size is the size of this array. So, if this max size reaches the last, means array is full. Heap size is the current number of elements present in the heap. So, this is gonna tell you the current number of elements, guys, how much the heap is filled up. Understood? Apart from it, let us move on. Now, these are the 3 helper functions to find out the parent, the left child and the right child for any particular node. And the formulas are: to find the parent, we pass that as I, and to find that parent, we will use this formula I minus 1 divided by 2, I minus 1 divided by 2. This will find the parent of any particular element, guys, inside that particular array. Okay, I minus 1 divided by 2, we will do it, it will give us the element parent. In the case of this, guys, okay, the formula is I minus 1 divided by 2, I minus 1 divided by 2. I want to find this parent, I 1 minus 1, I minus 1 divided by 2, which is going to be 0 index. I minus 1 0, 0 divided by 2, 0, 0 index, we got that means the parent is 100. If I value is 1, that means this 40. I hope so that this is very much clear. Similarly, here also 2, I minus 1 divided by 2, 2 minus 1 divided by 2, it will give you this. I hope so that this is very much clear to all of you. Understood? That is the formula for returning the parent. Left child we already know 2 into I plus 1, and right child that is 2 into I plus 2. Understood this really well, guys? Okay. Now heapify function we have written, don't worry, we will talk about this later on. Right now skipping it, whenever we will talk about that, I will talk about that later on. In a particular, see, in the insert function we will not use the heapify, but in the deletion function we will use the heapify. So when the deletion function or extract function basically we will do, at that time I will explain you about what is the heapify function. Just don't worry, I am not skipping it, okay, I am not rushing it or I am not skipping it. Understood? So yeah, in the public section of the max-heap class, I have taken maximum heap, the constructor here, and we have initialized the whole array. So we have initialized the max size with the max size. So whenever this is, because this is a class max heap, so if the user wants to use this, program, they will use it like this. First they will create the max heap object, correct? They will create the max heap object, and when they create the max heap object, they will have to give the size also to the array. How big is your heap? Based off of that, the heap will be created. Hope so that this is very much clear. So in the constructor of the heap, max heap, we have said that the max size equals to this max size. So whoever creates whenever you create the object of the max heap class, it will automatically set the size to whatever the maximum size, because we know this max size was the size of the array, if you remember correctly, right? And heap size is what? The current number of elements present inside the heap, which is 0 right now because we have not entered anything. So I have said heap equals to 0 initialized. Then we need to allocate the memory dynamically also to the array, right? So that ARR which we have declared right up there, the ARR which we have directly done up there, we are allocating him the memory. How? Using the new keyword. Everyone knows about the new keyword. So I said ARR equals to new of type int and of the size max size. I have 100 times I have explained this logic, guys. If you have not understood this logic, please go ahead and watch my stacks concept. I guess that will be session number something 5 or 6 maybe. 5 or 6. I have explained you this how it works. Alright, guys. So this is it. This is destructor. Now this is totally optional. It's up to you. If you want to write it, you write it. Otherwise, don't write it. It was looking fancy, so I wrote it. Yeah, it was looking fancy, so I wrote it. This is the constructor. Now the opposite of constructor is destructor. Disclaimer: destructors do not exist in Java or Python. It only exists in C++. Why? Because we can create or delete the memory in C++, but we cannot do that in Java or Python, guys. Remember that. Okay. Do not make that mistake. Understood? Okay, max-heap. This is the destructor, not of max-heap. Basically, this symbol is called as tilde symbol. Now, this symbol will be right before your number 1 key in your keypad, in the main keypad, in your main keyboard, just above QWERT, just above your Q letter 1, and before 1 you will see this tilde symbol in your computer, in your keyboard. Okay, guys, so that tilde symbol and the name of the class, which means it's a constructor only, but with not symbol, means tilde symbol means not of constructor, means it is a destructor. I hope so that this is very much clear to all of you. Understood? Okay, and my battery is running low, and my battery is not running low now. I forgot to switch on my charger, but it gave me a lot of backup though. Well, come back to the point. Okay, this is the destructor here, not of max heap, and we are just using the dynamic deletion here, dynamic memory allocation delete function we are using in order to delete the array itself. Now this is totally optional, bonus point, bonus knowledge, but if you don't know about this, yes, now you know about it. Okay guys, this is the insert function. Now guys, insert function is a pretty big function and I need to explain this to you properly. I will do that in tomorrow's class. Now the three functions are left: insert, extract and delete. Insert, extract and delete. So we will talk about this in tomorrow's class. Time is already over and I don't want to stretch this class anymore, and my camera also went off. Okay guys, we'll be back. Yeah, we are back actually. Well, I hope so that this is very much clear to all of you guys, and I hope so that you have liked and understood today's video guys. I hope so that you have understood today's session guys. So if you missed anything from this session, you can go ahead and watch it back again. This session will be recorded and kept into our DSA live placement series. So if you missed this, you can go ahead and watch that. Before watching this video guys, I would highly recommend to go ahead and watch our previous session video, so that you will understand and you are able to relate the concept between heaps and priority queues, which is very more important. That's all for today's class guys. I hope so that today's class is very much clear to all of you. If you have any doubts, I am here for your doubts for the next few minutes. If you are asking the doubts, I will continue the class. If you are not asking the doubts, I will turn off the session. But if you have any doubts, we can start our doubt session now. Out of whatever I have explained in today's class, if you have not understood anything, please do let me know. I am here seeing your live chat, live clearing your doubts. If you have any doubts, please do let me know right now. This is the doubt session now. End of the session and doubt session got started. So if you have any doubts, please let me know. I am able to see your chat. Related to this program, we will continue this tomorrow. In tomorrow's class, we will be finishing this off. Heaps will be over by tomorrow, and probably after that, I can start with the graph data structure. Chikkappa YR, please sir, it would be really helpful. What doubt you have? Chikkappa YR, if you have any doubt, please do let me know. What needs to be clear? Chikkappa YR, please tell me in the comment section. I will give the link of this particular notes, my notes, in the description, and please do see that. Any doubts, please? I can see your chats, guys. Well, because the session is about to end, let me just do my final thoughts to what I have done today. Today we have done heaps. We have understood the concept of heaps. We have understood how heaps they work. We have understood what are the types of heaps, what are heaps related to, priority queues, everything we have understood in today's class guys. Thank you so much for watching. Tomorrow's class I will be continuing with heaps, and by tomorrow we will finish up this class of heaps, and probably we'll start with the graph session very soon. So if you have liked this session, please give me a thumbs up, and please do like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also, so that you won't miss any future updates. Also keep supporting me like that. It motivates me to bring more and more videos from DSA concepts for you guys when I get support like this. I hope so that everyone is clear what I have said and explained in today's class, correct? And we'll continue this class tomorrow again. Tomorrow guys, same time, 7 o'clock Indian Standard Time, I'll be back and I'll be continuing with the heap session. Yes. Sir, could you please explain the program of algorithm code with example line by line with respect to example like Abdul Bari half knapsack? Yes, explain the algorithm of the code with the example line by line. Yes, I will explain the code, but this code will be explained in tomorrow's class. I have not started with the code explanation yet. Chikkappa YR. This I am going to do it in tomorrow's class. What you are asking is will be done in tomorrow's class. So don't forget to attend my tomorrow's session. Understood? Don't forget to attend my tomorrow's session. Tomorrow same time, 7 o'clock. Yeah. Yes, I'll explain. Don't worry. I'll explain. Okay. And in tomorrow's class, I'm going to explain the code properly. So don't worry, I have not started the code explanation, but I have explained you all the theory part for this, guys. Any other doubt? And yeah, so don't forget to like, share and subscribe as I was continuing, and don't forget to please follow us on Telegram. Please do follow us on Telegram, because that is the place where the most crowd will be created, and we are able to talk to you, we are able to understand what's your problem. We are going to put the updates on Telegram related to any kind of mock interviews or in fact internships, or in fact placements, or in fact new course. If you want the course from me, I am open for that also. My batch is going to get created in the next month. By 5th of October, my batch will be full, and then I will not be able to take up anyone. So please, if you are interested into the batch, please do let me know. By 5th of October it will be full. So guys, make sure that whoever wants DSA concept crash course, we have crash course, we have 30 hours, we have 60 hours, we have 120 hours course for placements, and we will also provide placement opportunities for the people who are joining our courses as well. So if you are interested, please do let me know. We have the contact on Telegram. You can contact us on our company's number, and I will be able to assist with you guys. Okay guys, I hope so that this is very much clear. Okay, it would be really better if you do together side by side, sir. Yes, I will do it. Tomorrow's class, I will do it. Okay. Any other thing? Any other specific thing that we need to do? Yep, I guess so. That's it. Well, I will be closing up the session, guys. Then I'll be closing up the session, guys. Then fine. Then, guys, thank you so much for watching. Don't forget to like, share, subscribe as always, and don't forget to follow us on Telegram. We'll be posting, and if you want any type of course, if you think that YouTube on YouTube this course is getting stretched out a little bit and it is taking a lot of time, you can join our in-house batch. In our in-house batch, we are also providing the placement assistance as well. So we can go and take you to many different companies if you join our courses. So guys, please contact us onto our Coders Arcade number. Number is going to be given already in the Telegram before. Telegram link is already given in the description as well. That's it, guys. Thank you so much for watching. I hope so that today's class was very you have understood this really well. Apart from that, that's it for today's session, guys. I'll be closing off the stream, and I'll see you guys tomorrow. Tomorrow at the same time, 7 o'clock Indian Standard Time. I'll be back, and I will see you again. We'll continue from this class, guys. Thank you so much for watching. Till then, take care. This is Ashank David signing off. Till then, take care. See you till tomorrow.